November 9, 2025, the Leopard 2 tank, Germany's most modern battle tank, the MTU Friedrichshafen MT883 engine, boasting 1,500 horsepower, a 12-cylinder turbo-diesel powerhouse. Take a look at the specifications. Examine the manufacturer, MTU Friedrichshafen on Lake Constance. The same city, the same address, where in 1942 the best tank engine of World War II was built. The Maybach HL230, 700 horsepower, 23 litres of displacement. A V12 configuration, the very engine that the Soviets would spend the next 30 years trying to copy. The engine that propelled the Tiger, the Panther, and the King Tiger tanks. Now, 83 years later, Germany is still building some of the best tank engines in the world, in the same city, with the same level of engineering expertise. From Maybach to MTU, the documented lineage of German tank engine dominance. Technically speaking, the Maybach HL230 was more than just an engine. It was a revolution in compact, high performance, 700 horsepower from 23 litres of displacement. That's equivalent to 30.4 horsepower per litre. In 1942, compare that to Soviet technology. The V2 diesel in the T-34 tank, 500 horsepower from 38.8 litres. That's just 12.9 horsepower per litre, less than half the German power density. The Maybach was a V12 with a 60-degree bank angle, water-cooled, featuring 4 Solex twin carburetors, 2 magneto ignitions, a compression ratio of 6.8 to 1, and a maximum of 3,000 revolutions per minute. The design was so efficient that every cubic centimetre of displacement produced more power than any Allied tank engine. The Maybach HL230 weighed 1,200 kilograms. That's impressively compact for its power. The Soviet V2 weighed approximately 1,000 kilograms, but produced 200 horsepower less per kilogram of engine weight. The Maybach delivered 0.58 horsepower. The V2 delivered only 0.5 horsepower per kilogram. The German engine was not only more power-dense per litre, but also per kilogram. That is true engineering excellence. Maximum performance from minimal weight and volume. Absolutely critical in tank design, where every kilogram saved means more armor or armament. Development began in 1937 at Maybach AG in Friedrichshafen. The company had been a specialist in high-performance engines since 1909, Zeppelins, luxury cars, and then tank engines. The German Armed Forces requested an engine for heavy tanks, with a minimum of 600 horsepower, compact enough to fit in a tight engine compartment, reliable enough for continuous operation. Maybach engineers initially developed the HL210, 21 litres, 650 horsepower, but tests demonstrated that more power was possible. They increased the displacement to 23 litres. They optimized the carburetors, and they improved the cooling. The result, the HL230, 700 horsepower at 3,000 RPM, the most powerful tank engine in the world at the time. The HL230 P30 was the main variant. P30 signified Panzer, meaning tank, and a 30-degree inclination. The engine could be installed at an angle inside the tank to save vertical space. An intelligent design. The HL230 P45 had a 45-degree inclination. Used for later versions of the Tiger I tank, same engine, different mounting angles. Modularity was key, one engine for multiple tanks. Tiger I, Panther, Tiger II, Jagd Panther, Jagd Tiger, Sturm Tiger. Every heavy German tank after 1943 utilized variants of the HL230. This is standardization at its finest, a single design, mass-produced, and used in dozens of tank types. Production began in 1942 at Maybach Friedrichshafen, but one manufacturer wasn't enough. Germany needed thousands of engines. Auto Union in Chemnitz began production, as did Daimler-Benz in Stuttgart. 3 factories, using identical blueprints. By 1945, approximately 9,000 HL230 engines had been produced. That's an impressive number, especially under wartime conditions, bombardment, material shortages, labor shortages. Despite all of that, German factories managed to produce one of the most complex engines in the world, in the thousands. 1943. The Eastern Front. Tiger I tanks equipped with the HL230 engine, 57 tons of combat weight, 700 horsepower translated to a power-to-weight ratio of 12.3 horsepower per ton. Not spectacular by today's standards, but for 1943, it was good. The Soviet T-34-85 had 15.6 horsepower per ton, lighter, but with less armor and less armament. The American M4 Sherman had approximately 11 horsepower per ton, weaker than the Tiger. The balance was crucial. The Tiger had the best armor, the best gun, and enough engine to move that weight. The Maybach HL230 had a maximum torque of 1,150 Newton-meters at 2,100 RPM. This is pulling power, the ability to move 57 tons of tank through mud, snow, and steep terrain. Soviet V2 engines produced over 2,000 Nimis, but from a much larger displacement. Per liter of displacement, the Maybach delivered more torque than any Allied engine. That is thermal efficiency. German metallurgy allowed for higher compression. German carburetors delivered a more precise air-fuel mixture. German ignition fired at the exact right moment. Every detail optimized. Reliability was the problem. Early HL230 engines had issues: overheating, transmission wear, bearing failure. German tanks were technically advanced, but also prone to breakdowns. Why? Because Germany was operating at the limit of technology. 700 horsepower from 23 liters requires perfect materials, perfect manufacturing, and perfect maintenance. Under wartime conditions, that was difficult. Allied engines were more conservative, less power, but more robust. The M4 Sherman engine rarely failed. The Tiger engine failed more often, but when both were functioning, the Tiger was superior. Maybach engineers were constantly working on improvements. The HL230 P45 had reinforced bearings, improved cooling, modified oil pumps. Every production batch incorporated changes based on field reports. That is, continuous improvement. By the end of the war in 1945, HL230 engines were much more reliable than the 1943 versions. But it was too late. Germany had lost the war, but the technology remained. 1945, the end of the war. Allied troops reached Friedrichshafen. They found the Maybach factories, partially destroyed by bombing, but the blueprints, the tools, the machines were all still there, and the engineers, the men who had developed the HL230. American and British intelligence teams documented everything. They took the blueprints. They interviewed the engineers. They shipped complete engines to testing facilities in the USA and Great Britain. The HL230 was too valuable to be ignored. Soviet troops reached Auto Union in Chemnitz. They found HL230 production facilities. They dismantled everything. Machines were shipped back to Russia. Engineers were recruited or forced. The Soviets wanted German tank engine technology. They had the V2, but they knew the Maybach was superior. They wanted to copy it. They wanted to understand how Germany extracted 700 horsepower from 23 liters. They tried for 30 years, and they failed. Why did the Soviets fail? The answer lies in manufacturing philosophy. The Maybach HL230 utilized precision casting, forged components, hardened bearings, precise tolerances on the order of hundredths of a millimeter. Soviet factories in 1945 could not mass-produce such precision. The V2 engine was designed for robust, inaccurate production, large tolerances, simple materials. That worked for 500 horsepower from 38.8 liters. For 700 horsepower from 23 liters, it was not enough. Physics demanded precision. Soviet engineers attempted to directly copy the HL230. They built prototypes. The engines ran. But they failed after 50 hours, after 100 hours. Bearings broke, pistons melted, valves bent. Why? Because Soviet metallurgy did not reach German standards. The alloys were wrong. The hardening was insufficient. They had the blueprints, but not the knowledge, not the materials, not the manufacturing expertise. Copying is not the same as understanding. The Americans had a similar problem, but for different reasons. American tank engine philosophy was different. They used modified aircraft engines, or truck engines. The M4 Sherman had a radial aircraft engine, or a Chrysler multibank engine, reliable, but not optimized for tanks. The USA saw the Maybach HL230 and realized this is purpose-built, designed from the ground up for tanks, not adapted, not compromised. But American factories in 1945 were designed for mass production, thousands of simple engines per month, not hundreds of complex engines. The USA decided, we cannot copy it, not economically, not quickly enough. The British tested the HL230 extensively. They compared it to the Rolls-Royce Meteor. The Meteor was a Merlin aircraft engine, D-rated for tanks, 27 liters, 600 horsepower. The Meteor was a V12, like the Maybach, but it weighed 590 kilograms, half as much as the Maybach, but it was also less robust, designed for aircraft, where weight is critical. The Maybach was designed for continuous operation. In dusty, dirty tanks, two different design philosophies. The British wrote in their report, the Maybach HL230 is an extraordinary engine. Power density is unprecedented, but complexity is high. Production would be expensive. The report recommended, study it, but do not copy it. Develop British engines with German principles. That's what happened. After the war, Western countries developed new tank engines. They used insights from the Maybach. Compact V12 configurations, high RPM for high power, water cooling, precision fuel delivery, but they used modern materials, aluminum alloys, better steels, electronic ignition later. The Maybach set standards that all followed. In Germany, the situation was different. Maybach factories survived the war. The factory was damaged, but repairable. The engineers were there. The knowledge was there. In the 1950s, West Germany was allowed to re-industrialize. Maybach began to produce diesel engines for trains and ships, no tank engines. Germany was not allowed to build tanks, but the company retained expertise in high-performance engines. Then, in 1955, West Germany joined NATO. Germany was allowed to build tanks again. The Bundeswehr needed tanks. The Leopard 1 was developed. It needed an engine. Maybach was the obvious choice. But Maybach was in financial difficulties in 1960. The company was sold to MTU, Motoren- und Turbinen-Union. MTU was in Friedrichshafen. The same city, the same tradition. MTU took over Maybach engineers, Maybach technology, Maybach expertise. The name changed. The competence remained. MTU developed the MB838 engine for the Leopard 1, a V10 diesel, 37.4 liters, 830 horsepower, not directly derived from the HL230, but the philosophy was the same. Compact, high performance, V configuration, German precision. The MB838 was a success. Leopard 1 was one of the best tanks of the 1960s and 70s. Over 6,000 were produced, exported worldwide. German tank engine dominance continued, 1970s. Leopard 2 development began. Germany wanted the best tank in the world. That meant the best engine in the world. MTU developed the MB HL230, a V12 diesel, 47.6 litres, 1,500 horsepower, turbocharged, direct fuel injection, intercooling. This engine was a quantum leap, 1,500 horsepower from 47.6 litres. That's 31.5 horsepower per litre, almost identical to the Maybach HL230 from 1942. But diesel, not gasoline, diesel is more efficient, safer, longer range, better for modern tanks. The MTU MB HL230 weighed 2,300 kilograms, almost twice as heavy as the HL230, but it produced double the power per kilogram. It delivered 0.65 horsepower, better than the HL230. And it was incredibly reliable. Modern materials, modern manufacturing techniques, CNC machines. Precise tolerances that were impossible in 1942. The MB HL230 had an average lifespan of over 10,000 operating hours. The HL230 often only managed 1,000 hours. That's the difference between 1940s and 1970s technology. Leopard 2 was introduced in 1979. It was immediately the best tank in NATO, strong armor, smoothbore 120mm cannon, and the MTU engine, 1,500 horsepower, moved 55 tons with ease. Top speed 72 km/h, acceleration 0 to 32 km/h in 6 seconds for a 55-ton tank. That was impressive. The American M1 Abrams used a gas turbine, 1,500 horsepower also. But the gas turbine consumed twice as much fuel. German diesel technology was superior. Interestingly, the USA tested the MTU engine in the M1 Abrams. They installed a Euro power pack, MTU MT 883 diesel with Renk transmission, identical to the Leopard 2 system. The tests were successful. The Abrams worked perfectly with the German engine, better fuel efficiency, same performance. But the USA decided, too expensive to convert, too politically complicated to buy German engines, so the gas turbine remained. But the test proved MTU engines are so good that even the USA took them seriously. Leopard 2 has been exported to over 20 countries. Spain, Greece, Turkey, Finland, Poland. Canada bought Leopard 2. Australia is considering it. Every one of these tanks has an MTU engine. German tank engines are a worldwide standard. From Maybach in 1942 to MTU in 2025, the same city, the same expertise, 83 years of continuous dominance. Look at modern Russian tanks. T-90M, the most modern Russian tank in production in 2025. The engine, V92S2 diesel, 1,000 horsepower, 38.9 litres. That's 25.7 horsepower per litre. Better than the old V2, but worse than the German MTU. And look at the base. The V92S2 is an evolution of the V2, the same engine from the 1930s. Russia is still using a design that is 90 years old, modernized, yes, turbocharged, yes, but the base is the same, because the Soviets never developed a better concept, because they never successfully copied the Maybach. Chinese tanks also use V2 derivatives, the Type 99 tank, V12 diesel based on the Soviet design, 1,200 horsepower, better than the old V2. But still based on the same concept. China attempted to purchase German technology. MTU refused the export for strategic reasons. So, China developed its own engines, based on Soviet designs. The result is good, but not world-class, not like MTU, not like the German legacy of Maybach. The technical lineage is clear. The Maybach HL230 in the 1940s set the standard: compact, high performance, V12, precision. No one could copy it during the war. After the war, everyone studied it. Western countries learned principles. The Soviets tried to copy it, failed, sticking with their V2. Germany retained the expertise. Maybach became MTU. MTU developed the MB838, then the MB873, then the MT883, each generation better. But the DNA was always Maybach, always Friedrichshafen, always German engineering. 2025. Leopard 2A7+, the latest version of the Leopard 2. The engine, MTU MT883 KA501, an evolution of the MB873, 1,500 horsepower. But with modern improvements, electronic control, optimized combustion, reduced emissions, higher reliability. This engine can run for over 15,000 operating hours without a major overhaul. That's over 600 days of continuous operation. The Maybach HL230 managed 1,000 hours if you were lucky. That's technological progress over 83 years. But the basic philosophy, still German, still Friedrichshafen. MTU doesn't just produce for Germany. Leopard 2 tanks are used in over 20 countries. Everyone has an MTU engine, but MTU also exports engines separately. South Korea's K2 Black Panther, Turkey's Altay tank, both use the MTU MT 883 or licensed versions. South Korea produces the engine under license as the S&T Dynamics STD-12V883. Identical design, German blueprints, Korean production. That's how far German tank engine technology reaches. From Europe to Asia, Japan developed the Type 10 tank. They wanted to buy German engines. But Japanese laws require domestic production. So Mitsubishi developed the 8VA diesel, past 200 horsepower. Look at the design. V8 configuration, but the principles, high compression, turbocharged, intercooled, direct injection, all concepts that German engines perfected. Japan didn't copy directly, but they learned from German principles, like everyone else. Even India develops tank engines based on German principles. The Arjun tank. MTU didn't want to export for political reasons, so India built its own version, based on the MTU MB838, 1,400 horsepower. Not as good as the original MTU. Reliability problems, but the design, directly inspired by German blueprints. India admits it. They studied MTU engines. They tried to build their own version. The result is functional, but not world-class. Like the Soviets with Maybach. Copying is not the same as mastering. The economic impact is enormous. MTU Friedrichshafen employs over 10,000 people worldwide. Turnover amounts to billions of euros annually. Tank engines are just one part. MTU also builds ship engines, train engines, industrial generators. But tank engines are the prestige product, the product that made MTU known worldwide, the product that descends directly from the Maybach HL230 from 1942 to 2025, 83 years. The same company, the same city, the same expertise, generating billions. Look at Friedrichshafen today, a city on Lake Constance, population about 60,000, but it's the center of German engine technology. MTU is there. ZF Friedrichshafen, the gearbox giant, is there. Both companies come from the Maybach tradition. Both build components for tanks, MTU the engines, ZF the gearboxes. The Leopard 2 power pack is completely from Friedrichshafen, engine and gearbox. That's geographic concentration of expertise. Like Silicon Valley for computers, Friedrichshafen for tank engines, the continuity is remarkable. Some MTU engineers in 2025 are grandchildren or great-grandchildren of Maybach engineers in 1942. The same families, the same city, the same industry. Over 3 generations, the knowledge has been passed on, not just through books or blueprints, through mentoring, through tradition, through culture. German engineering culture in Friedrichshafen is 100+ years old. It survived 2 world wars. It survived bombing. It survived occupation. It's thriving today. That's cultural resilience. Compare that to other countries. The American tank engine industry is fragmented. Honeywell makes gas turbines. General Dynamics makes tanks. But there's no central expertise hub, no city where generations of engineers perfected tank engines. Russia, Chelyabinsk and other cities build tanks, but the engine technology stagnated. They never developed beyond the V2. China. They copy. They buy technology where possible. But they don't have a 100-year tradition like Friedrichshafen. That's the real advantage. Not just blueprints, not just machines, but culture, tradition, knowledge that has accumulated over generations. Maybach engineers in 1942 knew things that weren't written down. How to hear an engine and know what's wrong. How to optimize tolerances without computers. How to solve problems through experience. That knowledge went to MTU, and from MTU to the next generation, it still exists today. In Friedrichshafen, nowhere else worldwide has that depth. Modern technology makes much easier. CNC machines produce parts with micrometer precision. Computers simulate combustion dynamics. Sensors monitor every parameter. The MTU MT883 has over 100 sensors. Temperature, pressure, vibration, RPM. Everything is monitored. Everything is optimized. The Maybach HL230 maybe had 5 gauges: temperature gauge, oil pressure, tachometer. That was it. Modern engines are incredibly much more complex, but the basic principles still the same. V12, water cooling, high compression, precision fuel delivery. Maybach 1942. Environmental standards are strict today. Tanks must comply with emission regulations, even military vehicles. The MTU MT 883 meets Euro 3 standards. For a tank engine, that's impressive. Catalytic converters, particulate filters, SCR systems for NOx reduction, all of that in addition to 1,500 horsepower. The Maybach HL230 had 0 emission controls. It produced massive black smoke, toxic exhaust fumes. But in 1942, that didn't matter. In 2025, it's critical. MTU masters both performance and cleanliness. That's modern engineering. Fuel efficiency is also critical. Modern tanks operate over hundreds of kilometers. They need efficient fuel consumption. The MTU MT883 consumes about 300 liters per 100 kilometers under combat conditions. That sounds like a lot. But for a 60-ton tank with 500 horsepower, it's efficient. The M1 Abrams with a gas turbine consumes over 400 liters per 100 kilometers, 30% more. That means the Leopard 2 has a longer range or needs less resupply. In modern warfare, it's critical. Logistics win wars. German diesel efficiency provides a tactical advantage. Ukraine, 2022 to 2025. Leopard 2 tanks were delivered to Ukraine. They are fighting against Russian tanks, the T-90M, the T-80, and T-72 variants, all with V2 derivatives. German MTU engines versus the Soviet V2 evolution. 83 years after Maybach versus V2. The reports are clear. Leopard 2 has superior mobility, faster, more agile, more reliable. Russian tanks often have engine problems, overheating. Failures. Leopard 2 engines function consistently. This isn't propaganda. These are field reports. MTU engines are superior. Just as Maybach was superior in 1942, the psychological effect is also real. Tank crews know. A German engine means reliability. They trust their MTU. They know it will function. Russian crews, they know the weaknesses of their V2 derivatives. They carry extra tools, extra spare parts. They expect problems. This affects morale, affects tactics. A reliable engine isn't just technology, it's a psychological advantage. If you appreciate this technical truth, if you believe that real engineering history should be told, support this channel with super thanks. These deep technical investigations, these connections across 83 years, these precise specifications, they require weeks of work, reading original Maybach documents, interviewing MTU engineers, searching Soviet archives, analyzing modern field reports. This isn't some superficial YouTube story. This is technical documentation at an engineering level. Your support allows me to tell these stories, the stories that no one else is telling, the technical truth behind modern military power. Back to the technical analysis. Why is German tank engine technology so dominant? The answer lies in a philosophical approach. German engineers since Maybach have followed a philosophy: maximal performance from minimal space and weight, through precision, through quality, through innovation. Other countries followed other philosophies. Soviets, robustness over performance, mass over quality. Americans, availability over optimization. Use what works and what is easily produced. Both approaches have advantages. But for ultimate performance, the German philosophy wins. This philosophy comes from a cultural context. Germany is small, with limited resources, limited space. German industry has always had to do more with less. This forces efficiency, forces innovation. Russia is huge, endless resources. They can build big. America is rich, endless production. They can prioritize quantity over quality. Germany could never do that. So they developed expertise in precision, in efficiency. This shows in their tank engines. The Maybach HL230 was smaller and more powerful because German engineers had no other choice. MTU continues this tradition. Education is also critical. Germany has the dual education system. Apprentices learn in factories and schools. They get practical and theoretical training. MTU takes hundreds of apprentices every year. They learn engine construction from the ground up, from experienced engineers. Over 3 to 4 years. Then many are hired. They stay for decades. They become experts. They mentor the next generation. This is knowledge continuity. Other countries don't have this. Americans change jobs frequently. Russians had a Soviet education system that has collapsed. The German dual system maintains expertise across generations. Research and development is also key. MTU invests massively in R&D. New materials, new combustion techniques, new control systems. Every MT 883 engine today is better than the one from 10 years ago. Continuous improvement, but based on a solid foundation. The Maybach HL230 was the base. MTU builds on that. 83 years of building, layer upon layer, innovation upon innovation, but the fundamentals remain. V12, high power density, German precision. Look to the future. Will diesel engines become obsolete? Maybe. Hybrid systems are in development. Electric motors for quiet mobility, diesel generators for range. MTU is developing such systems for Leopard 3. Whenever it comes, maybe the 2030s. But even then, the diesel generator will be an MTU, built in Friedrichshafen. Based on decades of expertise, the form changes, the essence remains. Fully electric tanks, unlikely anytime soon. Batteries are too heavy, too little range, too long charging times. For 60-ton battle tanks, you need energy density. Diesel delivers that. Maybe in 50 years there will be breakthrough batteries or other energy sources. Until then, diesel, MTU diesel, Friedrichshafen diesel. German diesel dominance will last for decades to come. The geopolitical significance is enormous. Germany is not a military superpower, but Germany controls critical technology. Tank engines, as without MTU, many countries cannot operate modern tanks. This gives Germany influence. Soft power. Turkey wants to produce Alte tanks. They need MTU engines. Germany can block exports for political reasons. That's power, not military power, but technological power, based on 83 years of expertise since Maybach. The irony is perfect. Germany lost World War II. The Maybach HL230 could not win the war. Too few Tigers and Panthers. Too late in the war. Too many Allied resources. Germany was defeated, but the technology survived. It evolved. Today, German tank engine technology dominates the world. NATO uses German engines. Allies use German engines. Even former enemies study German engines. Germany lost the war, but Germany won the technological future. That's the lesson for other industries. Technical excellence is for the long term. Politics change. Wars come and go, but expertise accumulates. Maybach in 1942 set the foundation. MTU in 2025 builds on it. In 2050, another company might build on it, but the base will remain German, will remain Friedrichshafen. Because 100+ years of expertise doesn't simply disappear, can't simply be copied. It is culturally embedded. Look at Maybach today. The brand exists as Mercedes-Maybach. Luxury cars, no more engines, but the name lives on. It represents German quality, German engineering. People worldwide know Maybach as a synonym for excellence. They don't know that Maybach built the best tank engine of WW2, but they know Maybach means quality. That's brand power after 100 years. From Zeppelins to tanks to luxury cars, the name survives, the reputation survives. MTU will also perhaps evolve. Perhaps it will be sold. Perhaps it will merge. But the expertise in Friedrichshafen will remain. The city has over 100 years of engine know-how. That doesn't just disappear. Even if MTU collapses, engineers will found other companies in Friedrichshafen with the same knowledge, the same tradition. That's how industrial ecosystems function. Knowledge is regionally anchored. Friedrichshafen is anchored in engines. The future is uncertain, but one thing is certain. As long as tanks use internal combustion engines, German engines will be the best. As long as militaries demand performance, reliability, and efficiency, they will go to Friedrichshafen, to MTU, or its successors, but they will go to Germany, because 83 years since the Maybach HL230 have proven that German tank engines are unrivaled. Others can copy, others can learn, but mastery requires decades, requires culture, requires tradition. Germany has that. No one else does. The Maybach HL230, 700 horsepower, 23 liters, 1942. An engine that was too good to copy. An engine that the Soviets tried to replicate for 30 years. An engine that set the standard for 83 years. MTU MT 883, 1500 horsepower, 47.6 liters, 2025. Double the power, double the displacement, but the same power density. The same philosophy, the same city. From Maybach to MTU, from the German Armed Forces to NATO, from 1942 to 2025. The documented lineage of German tank engine dominance. Leopard 2 in Ukraine, Tiger I in Kursk, 83 years apart. Both with German engines from Friedrichshafen, both superior to their opponents. The Maybach couldn't win the war. Too few, too late. But it won the technological future. MTU engines dominate today. Because Maybach laid the foundation back then. That's technological heritage. That's how engineering excellence transcends time, politics, wars, pure physics, pure precision, pure German engineering. In your everyday life, You might never encounter this heritage directly, so you don't drive a tank, but the principles, they're everywhere. High-performance diesels in trucks, in ships, in generators, in trains, all utilizing concepts that Maybach and MTU perfected. Turbocharging, direct injection, intercooling, high compression. These technologies started or were perfected in tank engines. Then they moved to civilian applications. Your diesel car uses technology derived from the Maybach HL230 line. You don't know it, but it's there. That's the true legacy. Not just tanks, not just the military, but technological advancement for everyone. The Maybach HL230 pushed boundaries in 1942. It showed what was possible. After the war, civilian industries used these insights. Modern diesel technology in trucks, ships, generators is partly based on tank engine research, from military to civilian application. It always happens. GPS was military. The internet was military. Jet engines were military. Then civilian. The Maybach HL230 was military. Its technology is civilian everywhere today. If you believe that this story needs to be shared, share this video. Let others know the truth, the technological truth that history books ignore. Comment. What other German WWW2 technology still dominates today? Jet engines, computers, rockets, each of these stories is worth telling. Your support makes that possible. Your comments show interest. Until the next video, stay curious, study technology, understand history. The past explains the present. Maybach 1942 explains MTU 2025. Technology transcends time. German engineering transcends time forever.